Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we'll discuss question number 34 of NEET Physics paper 2017. Students will solve question number 34. It says that consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. Supposing that this is a raindrop and falling from a height of 1 kilometer. So this is the ground and it's falling from 1 kilometer. This is a height h. H is this one. It hits the ground with a speed of, when it hits the ground, its speed was 50 meters per second. So velocity when it hits the ground is 50 meters per second. If g is constant with a value of 10 meters per second square, the acceleration due to gravity is taken as strain and is a constant throughout this path. The work done by the first question is to find the work done by the gravitational force, so work done due to gravity. The second one is resistive force of air. You have to find the work done by air resistance. So we have two answers, 1 and 2. So we have two answers given. In each of the options we have to find the correct one. Now basically when air resistance is considered, so better we have to look for work energy theorem. So if in case of many works being done, then we will go for work energy theorem. The work that is known will be written and the unknown one will be found. The work energy theorem states that the total work done, the work energy theorem, it says that the net work done, that is the total work done by all the forces involved, by all forces, that is equal to the change in kinetic energy, the change in kinetic energy. So if I think of the raindrop falling down, it starts with initial velocity 0. When it hits the ground, it hits with a velocity v, final velocity, which is given as 50. If the mass of this is m, the drop is m, then it is initial kinetic energy here, kinetic energy initial will be half mu square, which is 0. The final kinetic energy kf equals to half mv square, whatever is the value we have to put. The mass of the drop is given as 1 gram. So this mass is given as 1 gram. In kilogram it is minus 3 kilogram. Okay. So this is the thing, the right part is solved. The change in kinetic energy is final kinetic energy minus initial kinetic energy. So this minus 0, so obviously it will be half mv square. Now the work done by the forces involved is that when it falls, the gravitational force will act downward direction, the air resistance will be acting in the upward direction. That means we have this drop is being subjected to two forces. One is the force that is acting due to gravity, another is the force that is acting due to air resistance. in the opposite direction to the velocity. So you have to find the total work done and there is no other forces. So this net work done by all the forces means the total work done due to these two forces will be found. Now the theorem, according to theorem, work done by the gravitational force plus work done due to air resistance is equal to the final kinetic energy minus initial kinetic energy. Now substituting the values, will get work done by gravity, that the drop is falling in this direction, that is the displacement is in this direction, and the gravitational force is also in this same direction. So work done will be force dot s, that is mg dot s, that is h is the height that is covered, so it is only mgh, which is positive work done, because the body is moving in the direction of force, plus the work done by air resistance. This is to be found because that is to be required, and also work done by gravity is required. Work done by gravity just comes out to be f dot s vector, which is mg vector dot of s vector, and this mg and s are in the same direction, so this angle is 0, so it is mgs cos of 0, so this is mgh. This is the work done, and that comes out to be m is 10 raised to minus 3 kilogram, g is given as 10 in the question, and height is 1 kilometer, that is 10 raised to 3 meter. So everything is in SI system, so the work done will be in joule. This comes out to be 10 joule. This will cancel, 10 joule. So the first option, the answer should be 10. Here it is 10. So this should be the correct answer because there is no other options containing this. But still, we'll find this value. Work done by air resistance. In your exam, if you get this one, questions like this, then you tick this one. Don't go for, because there are no other options. So you don't have to find this in your exam. But here we will also find the work done due to air resistance. Now this is equal to half of mv square minus 0, because initially the drop was being released. Now mgh, that is 10, we have already calculated, plus work done due to air resistance is equal to half mv square, m is 10 raised to minus 3 kilogram, into v square is 50 square, that is 50 into 50. So from here the work done by air resistance will be, this is 25, 20 will cancel with this minus 3, so 25 divided by 10, and this is 25 divided by 20, because this 2 is there, so 25 20 minus 10, because this 10 goes to that side, so this is actually 5 by 4 minus 10, it is actually 414, 1.25 minus 10. You can see that this is negative because this is larger than this number. This comes out to be 8.75. 8 plus 1, 9, then 10. This comes out to minus 8.75. And we have seen earlier also, it was 8.75 minus joule. This much of negative work is done by air resistance, so this much of joule. So the options and the answers I have already done. Just let me tell one more thing, that why the work done by gravitational force is positive and why the work done by air resistance is negative. Because the body was moving in this direction, it is falling like this in this direction. This was the direction of velocity. The gravitational force was acting in the same direction, so it was doing positive work, and the air resistance was acting in the opposite direction. When the body is moving opposite, exactly opposite to the direction of force, then the work done will be negative. Negative work done means the energy is being taken away from the body, and positive work done means the energy is given to the body. So this gravitational force is adding actually energy to the body, therefore the speed is increasing, and the actual speed which was supposed to be increased is decreased because of the air resistance. Okay, thank you.